Hello, today we'll be going over the data structure of stacks in C++. So last time we talked about queues where it follows the principle of first in, first out. Well, stacks is kind of the opposite where it follows last in, first out. So queue is, they call it FIFO, which is first. And then the stack is last. Yeah, so I guess one way we can think of it is, let's say we have this tube or something. If something goes in it for queues, it can come right out, so you can access it here. You can put it in here. And for stacks, on the other hand, you can think of it as kind of it's blocked here. So whatever you put in, let's say you put in the element 1, and then you put in 2. You can't really access the element 1 until you take 2 out. So when you try accessing the element in the stack, you're going to get 2. Whereas, let me just find for a queue, if you put in the element 1 and then 2, if you try accessing element 2, you can't do that. You have to access element 1 first. So yeah, just stacks, the only thing different is it follows last in, first out rather than first in, first out. So yeah, let's just try playing around with it. The header for using stacks is just this hashtag includes stack. So let's just say we have stack, and then you put your data type. I'm going to use int my stack. So basic operations, we have pushing into a stack. So push, say 1. So we have 3 elements in my stack. And if we want to visualize it, we put in 1 first, and we put in 2. So 2 is now going to be, I guess it's going to come out before 1, if you think about it here. And then we push in 3. So 3 is now going to be at the front. So yeah, if we do we're going to get the last element that was put into the stack, which is 3. Yeah, so we have 3. We can also get the size. Size, which we just do by doing this. So the last element was 3, so it's at the top, and then the size is also 3. And like always, we can also delete elements. And this is going to delete the top. So it's going to delete 3. So if we do this, we get, initially it's 3 is at the top and its size is 3, but after popping it's 2 that's at the top and the size is 2. And like queues, it's very similar to queues. We can do check if it's empty. We reuse the same thing we did last time. So it's obviously going to print null because we still have 2 elements in it. And yeah, those are the basic operations for stacks, where you can check the top element, which is the last element put in, you check the size, You can also take out the first element, or sorry, the top element or the last element in it, and you can check if it's empty. And yeah, so queues and stacks very similar in syntax. It's just that they function, you can think of it in the opposite ways. And that is basically all the basic operations for stacks. And thank you for watching.